Okay, so let's take a look at this example. It starts off by saying the Venn diagram shows the probabilities that a group of students like pasta, which is represented by event A, or pizza, which is represented by event B, as we can see here. It wants us to write down the value of X. Now, as we can see here, this Venn diagram is one that's not showing frequencies, but instead it's showing probabilities. It mentions it in the question. It's showing probabilities. We know that probabilities should add up to 1 for the whole sample space. Okay, so total is equal to 1 for sample space, since the sample space represents all the outcomes. So in this case, that first part is just simply a case of adding everything up. So we've got 0.4 plus X plus the 0.3 plus the 0.05, and that should equal to 1. And then if we rearrange that and find out what the answer is for that first part, make X the subject, X is equal to 0.25 in this instance. Okay, so then it goes on to say determine whether the events liking pasta and liking pizza are independent. Now, like pasta and like pizza are represented by the events A and the events B. We want to check if they are independent. So here, remember, independent is not visually seen from a Venn diagram. You need to use the condition for independent events. And the condition for events, independent events is, we will write that down first. So for independent events, probability of A intersect with B must equal to probability of A times probability of B. So we'll go and see what these are. So we're going to find out, first of all, probability of A intersect B. Now, A intersect B is the middle here, the intersection of A and B. Now, we've already worked that out. It happens to be 0.25. It's the X value that we worked out earlier. So we'll write down here 0.25. We'll work out what probability of A and probability of B are. So probability of A, we can see, is everything inside the circle A. So that's 0.4 plus the 0.25. So I'll just make a note here how we work out the probability of A. Probability of A is equal to 0.4 plus X, and probability of B would be equal to everything inside the circle B. So that would be everything that is 0.3 plus the X. So in this case, we can go and see what probability of A is 0.4 plus the 0.25, which is 0.65. Times by the probability of B, which is 0.3 plus 0.25, which is 0.55. We times them together to see that actually the answer on the right hand side is not equal to 0.25. So what we would write down, you could actually write down what it actually equals. It equals 0.3575 on the right hand side. And on the left hand side, the intersect of A and B is 0.25. Since they are not equal to each other, you would then say, therefore, A and B are not independent. Okay, so that's how we answer this question with regards to independence. Now, if it was mutually exclusive, we could have seen it from the Venn diagram, but we've also got the condition that probability of A union B is equal to probability of A plus B for mutually exclusive events. But in this case, we can see that clearly they are not mutually exclusive events.